taking the average of the operator applied twice. So it'd be a hat psi. Okay. So this is how we're defining the square of the uncertainty, right? And we're defining the uncertainty as the standard deviation, or sigma, if you like. All right. Now it just becomes mathematics, operator theory, if you like, and it will go on for well, this half of the session, another session below, and another, well, two more sessions after this one, just math. Right? Now, before I get into the derivation of the generalized Heisenberg uncertainty principle, I need a stepping stone. I need what the mathematicians would call a lemma, L-E-M-M-A. A lemma is sort of like a mini proof that's preparatory. You need a result that you need a prerequisite result, if you like. So this, in a sense, is a lemma. I need this result that I will use later in the derivation of the generalized Heisenberg uncertainty principle. And it's pretty famous in quantum mechanics. It's called the Schwarz. That's a German word, a name. It just means black. So some guy, black, Schwarz, invented this inequality, and it's a stepping stone. I'll need this result. Here is the Schwarz inequality, just written out here. Got an arrow to highlight it. Schwarz's inequality is a useful result that gets used deriving the generalized uncertainty principle. Right? So you have a bracket of A and multiplied by a bracket of B, and that result will be greater or equal to the bracket of A and B. The absolute value of it. So normally AB, bracket AB, is a complex number. Okay? So if you mod it, that means you get the absolute value of that complex number and square it. Right? So Schwarz's inequality says this. All right. Now how to prove this? So well, pretty standard technique. I must have several dozen, literally dozen, textbooks on quantum mechanics. So I can go looking from one to the other to try to find a simple, easy derivation. Sometimes the Schwarz inequality will be an exercise, and hence there's no answer given often. Or another textbook, and if, that's not very useful to me, so I go to another textbook until I find a derivation, and I may find half a dozen different derivations in different textbooks, and then I'll choose one that I think is the clearest and the easiest. Now, so this was not in it was not in Davies' textbook. He just mentions it, which I found was rather annoying because it's not terribly difficult. So, since it's such a useful stepping stone towards the generalized Heisenberg uncertainty principle, which is a very important result in quantum mechanics, I thought it would be important to include it here. So I've done it in detail. Virtually no missing steps because you really want you to get it. Okay, how to prove this? Proof. So. In mathematical terms, if you like, here's your theorem statement, the statement of Schwarz inequality, and here's the proof. Okay, so this is just a ket. Right? Just think of it as a wave function. And gamma. So let gamma be defined as ket alpha plus lambda. Now lambda is just some complex number constant. Okay. Ket beta, so alpha plus lambda ket beta. So bra ket gamma gamma, which you can think of as a ket. A ket is just a wave function, just the direct notation for a wave function. So think of gamma here as a wave function psi, and I put a little gamma subscript here as just an ID that it's it's the same thing as this gamma ket, this ket here, right? Now, if you bracket a state vector with itself, you'll get something that's positive. Why? Because remember the definition of bracket. So whatever the bra here, its wave function, you star, you conjugate it, you convert all the i's to minus i's, and so this the size is usually a complex function. You can think of it as u plus iv. So if you multiply that u plus iv by its conjugate, the conjugate will be u minus iv, and you multiply these two together, you'll get u squared plus v squared, and u and v are reals. So this square here is a positive, non-negative real number, right? So this, and hence bracket gamma gamma, is non-negative. So it's greater or equal to 0. Okay. Now, so we've got an inequality here now, and it's due to this inequality that we're going eventually we'll get this, right? Okay. All right. Now, plug in for gamma. Where is gamma? Here. So plug in your alpha plus lambda beta here. Now, now this is a bra. Now, remember you define the bracket this way. Whatever's here gets starred here. So the gamma is this. So if you star all that, this lambda will get starred, right? So that's why it's starred here. See, this is a bra, and that's a ket. Okay, so be conscious of that. So this complex valued constant here gets starred. All right. So all that. So there's the bra, and there's the ket coming from here. All that bra ket, the longer bra ket, is greater or equal to 0. Right. So now work that through. Multiply it through. So you'll get from these two alpha alpha, and if you multiply these two together, so you'll get lambda lambda star beta beta bracket beta beta. Right. That's where by multiplying that and that you get this. Right. Now, where does this come from? Lambda alpha beta. So if you multiply that and that, you'll get lambda alpha beta bracket. And this, if you multiply this by this, so you get lambda star beta alpha bracket. Okay? Expanding that out. Alright. Now it becomes a bit of a trick, and I'll run out of the board for the. Well, I've run out of this rectangle, so I'll just continue on smoothly in the next session. But okay, so you've got this expression for bracket of gamma gamma here, okay, and it's greater or equal to 0. So let's find this term, this sum here is obviously a function of the lambdas, of lambda and lambda star. So, and the whole thing, no matter what the alphas are, the betas are, the lambdas are, it's always going to be greater or equal to 0. So you may ask why. Well, usual answer, it works. Let's find the minimum value of this expression here, and we'll still know, whatever it is, we'll still know that it's greater or equal to 0. Right? Because this is a general expression. It doesn't matter what alpha, beta, or lambdas are. Right? We know whatever it is, it's quite general because gamma gamma bracket is greater or equal to 0 because of this. Because this you're squaring something. You're squaring the absolute value of a complex function. So that has to be positive or 0. Non-negative. Okay, so let's find the minimum value of this. So it just becomes calculus. the maximum and minimum. You take the derivative and let it equal 0. So then it has to be either a minimum or a maximum because the gradient is flat, 0. Okay, so differentiate this with respect to lambda, with respect to WRT. Okay, with respect to lambda. So differentiate that with respect to lambda. So you'll get lambda star here, beta beta, and you'll get alpha beta here, and all the rest 0. Right? Okay, so that has to be greater or equal to 0. And so therefore you can solve for lambda star. Just take this over the other side, divide by beta beta, and so on. And I'll just go on smoothly in the next session.